Hey guys, welcome back to Quanta and myself Viru sir, founder and director Quanta Institute, Jaipur. Guys, in this short video, I am going to discuss a very important topic in mathematical physics, or you can say in quantum mechanics. Okay, so the topic is derivative of step function, and before moving on derivative of a step function, first of all we have to understand what is step function. So let me see step function. Step function. So step function is, first of all I am talking unit step function. Unit step function is, and it is defined by theta of x, and it is, this is x axis and this is theta of x. So at x equal to 0, see the argument and put it 0, and obviously this will give you x equal to 0. So at, it is defined at x equal to 0, theta of x is defined at x equal to 0, and it is unit step function. So at x equal to 0, it takes a step of unity, means this will be 1. So delta function can be defined in this way. This thing will be 1 where x is greater than 0, and this thing will be 0, as you can see here, if x is less than 0. This is unit step function, and if you will call just step function, then here may be some constant a, and here you will write a. So this is unit step function, and it will be written this way, a theta x. Clear? And sometimes we talk about translated step function. Translated step function. What is translated? Translated means it will be defined at some point, not at x equal to 0. So it will be defined at some point a, at x equal to a. So it will do the same thing at x equal to a what it was doing at x equal to 0. So if it is unit step function, unit translated step function, then this will be 1, and it will be defined as delta x minus a, and this will be 1 if x is greater than a, and it will be 0 if x is less than a. So this thing is 0 here. So this is translated unit step function, and this is unit step function defined at x equal to 0. Now we have to see what will be the derivative of step function. Clear? So move. Derivative of step function, and let me discuss this thing by a question. So let me take a question, and this is in this way. This is a combination of step functions, and this point is a here, and this point is, this is some function, and you have to find the derivative of this function. Clear? And this is step function, mixing of step functions. So let me write it f of x, and you have to find f prime x. Clear? This is point a, this is 0, and this is point minus 3 by 2a, let 3 by 2a, and this is plus 3 by 2a. Clear? This is point, some let we take x equal to 1, this is point x equal to 2, this is point x equal to 3, and this is obviously x equal to 0. Derivative of this function यानी कि f prime x will be what? First of all, you have to notice the points on which step function is changing abruptly. First of all, you have to notice the points at which step function, or you can say function f of x, is changing abruptly. So these are points x equal to 0. As you can say, at x equal to 0 it is a, so it has been changed abruptly, suddenly. And again at x equal to 1, if you see x equal to 1 minus, then its value is a, and if you will see x equal to value of the function at x equal to 1 plus, then it's minus 3 by 2a. So again this is the point where step function has been changed abruptly. Again this is the point because at x equal to 2 minus, the value is minus 3 by 2a, and at x equal to 2 plus, value is plus 3 by 2a. And also this is a point where step function has been changed abruptly. You can see at x equal to 3 minus, the value is 3 by 2a, and at x equal to 3 plus, value is 0. So this is the first point. You have to notice all these points. Clear? Next, the derivative of this function, you can say f prime x will be Dirac delta function. And how you will write? See, final value, let me write here, d theta x over dx, derivative of step function, final value minus initial value into delta of x minus x naught, and x naught is point of discontinuity, as you can say x equal to 0, x equal to 1, x equal to 2, x equal to 3, these are the points of discontinuities. Clear? So now f prime x will be what? F prime x will be delta of x minus 0, and here it will be final value is a, and initially it was 0. So final value minus initial value into this one plus, so you can say the derivative of these kind of functions will be summation of this thing. Clear? So next one will be at x equal to 1, what is final value? Final value means at you can write here, this thing is f of x naught plus minus f of x naught minus final value minus initial value implies this thing. Okay, so final value is what? This one, minus 3 by 2a, minus initial value was what? This one, a, and transition point or point of discontinuity is 1 plus at x equal to 2, final value is what? Plus 3 by 2a, minus initial value is what? This one, minus 3 by 2a, minus 3 by 2 a and delta of x minus 2 plus at x equal to 3 what is the final value? Finally it is 0 value, 0 minus initial value plus 3 by 2 a and delta x minus 3. This is the derivative of this particular question, this particular function. Clear hai? Let me write very clearly. F prime x will be a minus 0 a and delta x minus 0 delta of x plus, and this will be what? Minus 3 by 2 a minus a. This will be minus 5 by 2 a minus 5 by 2 a delta of x minus 1 and plus, here it will be 3 by 2 a plus 3 by 2 a 3a and delta x minus 2 plus, this is minus 3 by 2 a, so minus 3 by 2 a delta of x minus 3. So this is the derivative of step function shown here. Let me take again one more question. Let you have a square wave and let you have this kind of a square wave. Okay, so let this is 0 and this is a, this is 2a and this is 3a and this is a and this one is minus a. Clear? So what will be the derivative of this function? What will be the derivative of this function? This is let f of x. So you have to find f prime x. Okay. So points are what? X equal to a 0, x equal to a, x equal to 2a, x equal to 3a. These are the points where function is changing abruptly. Okay. So here what you have to do? Final value minus initial value. Initially it was 0 and delta of x minus x naught means x minus 0 plus, here final value is minus a and initial value is a. So final minus initial and delta of x minus a plus at x equal to 2a क्या हो जाएगा? Final value is plus a minus initial value is minus of a, so it will be plus a, and let me write this way, and delta of x minus 2a and plus, here it will be final value is 0 minus the initial value is a and delta of x minus 3a. So this will be what? F prime x will be a delta x plus minus 2a delta of x minus a, and here it will be minus plus 2a delta of x minus 2a and plus minus of a delta of x minus 3a. So this is a very important concept in mathematics, the derivative of step function, and this is the formula, and I have done 2 questions. So I think concept is very clear. Let me write in the end a conclusive formula. Derivative of theta function or step function will be what? Final value minus initial value into delta of x minus x naught. X naught is the point of discontinuity and final value is f of x naught plus and initial value is f of x naught minus. So you can write it in this way. Clear? So this was all about the video, and let me see you in next lecture on variational method of approximation in quantum mechanics, and we will solve David J. Griffiths problems. Okay, bye bye, see you.